Hi, good evening, guys. Welcome to NextGen IT Courses, day 2 for SOC Analyst. Can anyone confirm if they can?
Good evening, sir.
Yes, thank you. Yes, we have our trainer with us, Mr. Imran. So, we can start with the day 2 class for SOC Analyst L1, L2, L3. So, over to you, sir, Imran, sir.
Thank you very much, Sachin. Hi, good evening. Good evening, everyone again. So, so we covered few topics yesterday regarding the network architecture, what are the roles of different components which we have in the organization with respect to firewalls, proxy, Active Directory, DNS servers, database servers. So, any questions you have from the previous discussion, please feel free to ask, or else we'll start with this session then.
Yes, guys, that's very important. So, you can ask your doubts and make interactive the session so that you will be like getting help for that.
Right, guys. As I said, this has to be an interactive session where you ask the questions, you clear your doubts. Otherwise, it will be one-way traffic. All right. It should be like a both-way traffic, which we call as it should not be a broadcast where I'm just sending out. If you guys should also come and ask the questions if you have any doubts. So since we don't have any doubts, we'll start with our session. As I said, like we'll be starting with network fundamentals. So why we need networks knowledge when we are talking about security? Anyone? So so I just wanted to give you a history of security. Right? So maybe let's go back 25 years back. Right? There was no security team. Right? Organizations used to have the one network team. They will configure the routers for you. They will set it up in the most efficient way to secure organizations. But as the internet reachability increased, so the cyber threats, the cyber landscape increased, and with the increase of cyber landscape, the cyber attacks increased as well. That's the whole story. So network team used to do the security part as well. So I'll just give you an example. Somebody who's working in the networks, working with the routers, right, at layer 3. So they have their access control policies, which can act as a policy which you create on the firewall as well. But that's a layer 3 device, right? And it helps you with the routing. So what is routing, what is switching, that will cover during this particular session. So what they used to do is they can configure the NAT on the file or the router at layer 3. So NAT is a network address translation. Again, this all will be covering. So any questions before starting?
No.
No, right. So very fundamental question. What is a network? We'll just read it out. A computer network is a system interconnected device. So you guys can read this out. It's just a basic uh, bookish language, I would say. But if we specifically talk about what is network, that we discussed yesterday, how the network is connected, right? Why it is important. So that if so, what is an internal network? What is external network? Anyone? So you all can see my screen, right? It's a paint screen I'm sharing.
Yes, we can see.
Anybody can confirm? Okay, thank you. So, okay, suppose this is our organization, right? And this is internet, right? Internet, maybe where we are working from, maybe the attackers are also sitting here. Anyone who wants to access our web applications are sitting here and accessing it. So what we call as the organization network. So network means we have many database servers. We have multiple servers for multiple functionalities which we use in the organization, and we have the user sitting in and connecting to those servers and accessing those applications and getting saving the files on the server, connecting to the internal system. So anything which is connecting, so and in network which is connecting your organization assets, right? That we call it as internal network, right? So suppose like you have at your home, you can set it up a LAN and you connect a printer or your machine. Yes, you have a server, then you set up server, then you can set it up a file server, database server. You want to set up a database, you have endpoint your laptops, you want to configure it, and you want to make a use of those system, and within your house you don't want the accessibility to the internet. Yes, you can set it up. That is what is done in the organizations, right? They set up their private network. That is what the internal network is all about, right? But again, since cyber is expanding, so you need to reach out to the cloud solutions. For that, you have to go through internet, right? SaaS is a software as a service, where you reach out to the vendors like Amazon, AWS, GCP, Google Cloud, Azure, or IBM Cloud, and there are multiple clouds as well. So that will also cover what type of clouds are available and what type of architecture they follow. So that's a different topic we'll be covering. So coming back to the topic, we have organization, we have our internal network, and what we call the network which is outside our organizations, that's external network, right? That's public network for us, right? So going back to the slide, so modern networks are essential for enabling the collaboration of remote access. As I said, anybody who wants to access the organization network, right? A user who might be sitting in his home using maybe Airtel fiber connection wants to access the organization network. Since he's sitting on the internet, he won't be able to access the organization's assets or servers or the applications from here. So what we do is we set up a VPN for them, right? That's a virtual private network. So this, so somebody who's sitting here having a laptop, having a VPN client, say if we talk about Palo Alto, he might be having Global Protect installed on his machine. So there are gateways assigned to that Global Protect. Once he open his laptop, connect through that, he asks for username and password for authentication. And on basis of that, it chooses the best gateway. What is gateway? Anybody? What is gateway? Guys, again, I would say yes, no, maybe. So let's make this discussion interactive. Else, I won't be able to know if you're getting the things or not, because these are real things. I could have read this particular slide and moved on to the next one, but this is what the real scenario is. So if somebody asks you a question, okay, what is a VPN? So how would you answer it? Okay, VPN is a virtual private network. Means you are not inside the network. You are sitting somewhere else, but still you are connected to the network. That is virtual private network, right? So somebody having a laptop with Global Protect connects to the nearest hub. It connects to the nearest Palo Alto in the data center. So they have a firewall in data center. Once the agent reaches out to the gateway, gets an IP assigned to this particular machine, and then from this machine you have two tunnels which are set up. One towards your internet, if you wants to go maybe to the sites which does not belongs to your organization, but if you have to access the applications related to your organization, then you follow this route. So what happens actually when somebody authenticates on the virtual private client, so the routes are being pushed from this firewall to this machine, and it states that okay, if somebody who wants to access my organization's website has to follow this route, and anybody who wants to follow maybe not this organization website has to go can go through his Airtel fiber web. wireless access. Any questions related to this? Guys,
Anyone,
yes, no,
guys,
maybe.
this is the basic, guys. You can answer, please.
No, you can continue.
Right. So again, I would say that network is an environment where you set up and connect the multiple devices so that they can talk to each other. In terms of technically, I will say they can exchange the data, get access the resources, and can maybe talk to each other. Eventually, we want the devices to talk to each other, and that for that we set up a network. So over the internet also, if you are accessing a web application, suppose google.com you are accessing, how it goes through? It goes through the layers, right? It has to pass the TCP/IP model layers, right? And then you reaches out to that server and get the details which what you want. So uh, so networks are the base for the security. So that is why we are covering network fundamentals. My first question when I started this session, right? So if you have to talk to anybody, you want to access wired network, wireless network, right? Voice over IP, data network. So for anything, you need to set up a network. So network devices, I mean, like you have wires, the cables, right? The Cat5, Cat6, maybe you would be having Cat6 cable in your home from where you are right now connected to your home router. And then you have the switches, you have routers, you have firewalls. Then you have hubs and switches. Hubs we don't use now. And then that there are multiple network devices which are connected and enables the communication from source towards the destination for different purposes. That is how it is. That is what it is. Right? If anybody wants to access the internet, network is required. Without that, you cannot do it, right? So if I specifically talk about the types of network, that is LAN. If you see my screen, so LAN is a local area network, right? So suppose we are working for an organization which has a data center in maybe Las Vegas, and then they have this LAN setup for their users. So LAN means you are doing it in a local area network. You get a subnet assigned to this particular area and connect those devices. Right? And then we have MAN. What is MAN? Is a metropolitan area network where you are connecting between a short area. So data centers are not far away, right, from each other, and then they could connect. That is what we call it as metropolitan area network. Whereas in wide area network, that's your internet, right? You are sitting here accessing something in the US. If you're sitting in, suppose you're sitting in Chennai, right, and you want to access something in Africa, right? That's WAN network, wide area network. There may be multiple routers coming in, multiple ISPs, uh, L3 level switches are coming in, and then gradually your traffic will be moving from either circuit switching or a packet switching way, through which you will be reaching out to your destination and getting the resources what you want to see. That is how it is, right? So if we specifically talk about the network, so these devices can talk to each other, right? This may be the servers, or the endpoints, the laptops, or maybe something else, right? If you have, what is something else? I mean, like the domain controllers are set up. They want to talk to each other, want to replicate the records, right, of the users, the machines, and everything which is there under the forest. So that is what how they talk to each other. So anything which is sitting inside one data center, right, and wants to talk to each other, that is known as east-west traffic. So please mark this. If you want to write this down, please write this down. East-west traffic, traffic which moves within the data center. Right? And what moves out of the data center, that's what we call as north-south traffic. Right? So suppose this is a data center where we have all our servers, they have switches, routers, firewalls, right? So suppose this server wants to talk to this server. So what we call it as east-west traffic. So now suppose we have this server who wants to talk something over the internet. So suppose we have this antivirus server and it needs some updates. It has to reach out to its vendor. Suppose we are using Trend Micro, right? And it wants to push some updates from Trend Micro Cloud. So that's over the internet. So what connection we call it as? It's a north-south traffic. Anything which is going from our network towards the internet, that is north-south traffic, right? Any questions with this?
No.
Right. So I think the types of networks are clear for everyone. Now I'll be moving. So I'm just moving fast because uh, we have to cover. We were not able to cover this network part yesterday, although we had a good session. But in case you have any questions related to networks, how it is set up, what is switching routing, when I'll be starting explaining what is switching and routing, then feel free to ask the questions. Okay. So moving to the fifth slide, this says OSI model. So we can say this is base of network. Anybody who knows about OSI model? Yes, no, maybe. So OSI model is open system interconnection. So this gives you a way how the traffic flows within the network, right? And reaches to its destination and brings up the data for you. So it might sound like uh, gibberish as of now, but this is how it is, right? We initially starts with the physical layer. So I have written it from top to bottom because it is. But when we start with the first layer, so anybody who is asking you the question in the interview, okay, tell me what protocols works on data link layer, right? Then you must know, okay, we have MAC working on data link layer. Why MAC is working on data link layer, that I'll cover. And then they might ask you, okay, what is ARP, address resolution protocol, or RARP, reverse address resolution protocol? So let me start with a diagram where you'll get a better understanding of it. So how you can learn this thing? So maybe this would be the first question who's getting interviewed for SOC analyst role. So please pay attention to it. So we have physical layer, then we have data link layer, then we have network layer, then a transport layer, then a session layer, presentation layer, then we have the application layer. So when I was saying that our new firewalls, the recent firewalls works on the layer 7, then I meant it they are working on the application layer, right? So how can you memorize this thing? So I'll give you a clue. You can remember them like, please do not throw sausage pizza away, right? Anybody who can come up with a new abbreviation would be appreciated. But what I learn, so what usually my students comes up and ask me, okay, how would I be able to learn this thing? There are many other lines which are available over the internet. You can go and read out, but this is the most perfect one, I would say. Please do not throw sausage pizza away, right? But eventually when you'll get into it, you will start like you don't have to remember by this thing, you know? So for a start you can start with these things, right? So what is a physical layer? Anyone? Guys, you're following me, you getting what I'm telling, or do you want me to slow up and explain something? Please feel free.
No, it is fine. Actually, physical layer is well, the physical devices like cables, right? Uh,
Absolutely. So when we talk about physical layer, so what physical layer does, it handles your transmission of data. So you have to transmit data from suppose A to B, you have a cable in between. So that is what is doing it for you. So it's a transmission of data in the form of bits, right? When you call it, you have to tell what form of the data will that be in when we are specifically talking about the layers, right? Here you will be seeing the raw formats that is in the form of bits, because your cable does not know what data it is flowing into. Your machine does not read anything. Your machine works in binary 0 or 1. Using wired or wireless does not matter. So different network topologies. So if we talk about topologies, we have bus topology, mesh topology, star topology. So these are the topologies which works, and they so means they are connected to each other via a cable, and the data which is transmitted between them is in the form of bits. So this is the keyword, right? When you are explaining. So transmission can be unicast, multicast, broadcast, and define how the data flows, right? So what is unicast? Anyone?
It is one way,
So it is one to one, right?
one to one.
One to one, right? And when we say multicast, so it's a unicast. So guys, I'm just giving you the topics, right? You just note it down. If you want to take the screenshot, you can take it, but please note it down the topics which are critical for SOC analyst role, right? So we will not go in depth of how routing is done, how switching is done, okay, how unicast, you show me how it can be done from the practical side, because that is not required from a SOC analyst role. That's a network administrator role. But to know this thing, because you will be engaging in with the network team, and you should know if you're checking the log and network log that okay, what is unicast, right? Is it a unicast or multicast? If you see a one source IP sending traffic to many destination IPs, right? That is a multicast. So one to many, right? So then we have a broadcast. Broadcast is one to all, right? And there is one more, right? That is anycast. So many people know about these things. So what they ask is anycast. Okay, what is anycast? Anyone? So it will be one to the best server. Okay, what is best server? So where my latency is low and this hub is nearest to me so that I can access the resources quickly, right? The speed is high. Everybody wants the speed to be high. So that is what we are having the CDNs for. So CDNs, what CDN does is content delivery network. You want to access YouTube. It won't go to the YouTube data center in the US and get the data for you. It will cause latency, or the network will be slow because it has to work around and go to the other continent and get the data for you. So what they do is they place the CDNs near you. That's the hubs. Host their sites on those CDNs. So that is what Anycast performs for you. So that is, if you want to access, it will find the best server near around, and then connect you and give you the resources which you are looking for. So I hope I'm clear with this thing, right? So again, when we are talking about the key performance metrics, we call it as the bandwidth. We see the throughput. Okay, what is a throughput? Guys, please note it down alongside me. Anyone who knows what is a throughput? Okay, so bandwidth means the maximum data capacity. So if we are having a link, right, 1 gigs, right? So that's the maximum capacity of that cable. It can carry up to 1 gigabits per second, right? So that is a maximum data capacity. So what is throughput then? So what we are actually getting from that, right? When you place a firewall and you have to set up the external link. What is external link? Again, I'm correlating now. External is the public network. So external means link means the link which is connected to the internet, where you have your ISP integrated, right? So what is the maximum bandwidth? Okay, so you get a 1 gigabit per second link from your ISP. So they charge you as per the bandwidth you are looking for. So you have to see what is the maximum bandwidth my organization would be needing, because your users from that particular data center will be going through that data center and will be utilizing this bandwidth, right? So you have to judge first, like, okay, this much bandwidth I need, and then you calculate what is the throughput, what is the actual I am receiving. So once you start the operation, you see, okay, this is what I'm actually receiving from this, right? So I'll give you a real-time scenario. When I was working in one of the organizations, uh, and one of the services went slow, it was not stopped, it went slow. Post the troubleshooting, I checked the throughput of that link decreased, uh, like it suddenly decreased, right? So what happened was that cable which was connected to the firewall, right, here, was not able to take that much data. Why? Maybe because of the fault in the cable, or maybe it has got old. But once I failed over to the another firewall, which was also having the same the same bandwidth and the throughput as checked. So once it was failed over to this link, it was working fine. So what I asked the on-site team to change the cable. Once it got changed, boom, everything was working fine. So this is critical, because if anybody is talking to you, okay, I want bandwidth, I want to check my throughput. So this is why we are discussing this thing. So, right. So now you know, right? What is the role of the physical layer? Any questions related to this? Anyone?
Yeah, anyone? Abhijit, Dinesh, Valoru, Manju, anyone?
No problem. Please continue.
Right. So you have, so when we talk about the physical layers, right, we have to divide the networks into multiple VLANs also, right? So when we are talking about dividing a single LAN into multiple VLAN, I mean the virtual LANs, right? Right. And if you're talking about virtual LANs, then we should talk about virtual private networks also. So when I showed you that example where somebody who's working from home opens a Global Protect client and wants to connect to the Global Protect gateway, that's a VPN, that's a remote VPN. And that users connect to the VPN, gets an IP assigned, which is there configured on the gateway, and access the resources of the organization. So that is how it is, right? So, and we have recent Palo Alto firewalls which are working on the virtualizations, virtual domains they are using. So you can create many virtual domains. So suppose you are working for an organization, right, that is providing security services to many organizations, and you have a big firewall installed. So what you can do is you can divide it into the parts, right? Just overview I am giving. You can divide into the parts, use it for one domain, one customer, use this part for the other customer. With the part, I mean you actually distribute the resources, right, amongst the domain, and you can use the same firewall, same setup for four customers from here. Anything you want to do, you just go to that domain, make the changes, switch to the another domain, make the changes. This is how it is done. Okay. So layer one devices, if we specifically talk about, right? So these are, you can say, hubs, repeaters, concentrators. So these handles the raw data in bits. So that is the main point, right? So when we talk about, so let's move to the data link layer. The data link layer, which works on MAC addressing and the framing, right? So data link layers, the devices which works on data link layer are bridge, but mostly when anybody asks you this question, what works on data link layer, answer them switch, layer 2 switch. We have layer 3 switches also, please don't get confused. So layer 2 switches, here the data flows in the form of frames, right? So that is very important. Here the data was flowing in the form of bits, but here the data flows in the form of frames, right? So what is the MAC address? Anyone? What is a MAC?
Physical address of the device.
Absolutely. So that is what we call it as media access control. Can you tell me how many bits of a MAC address is? So this is favorite question for the interviewer. So they ask you how many bits of a MAC address is. You answer them 48 bits when we are using IPv4,
48 bit.
and you tell them we use 64 bits
64
when
on
you are
IPv6.
when you're working with IPv6. Exactly. Right. So what is switching? We'll just see what is a MAC, why we need it. So why we need media access control? That's a physical address of your system. Suppose you all maybe connected through a phone or a laptop, right? So this machine has a physical address. That is what we call as a MAC. But again, at the same time, you would be having an IP address, right? Because your MAC cannot go over the internet and bring the resources for you or connect you through the Zoom for this meeting. So you have the IP addresses. We call it as a logical address, right? That's a physical address MAC, and we have IP address that's a logical address, right? So when we talk about switching, what is switching? So switching generally happens on layer 2, right? We have two types of switching, right? One is circuit switching, and the other is packet switching. So in circuit switching, you have a dedicated path. Suppose you have one machine here, you have a dedicated line connected. So these two devices are connected to each other. That is known as circuit switching. But when we talk about packet switching, there is no dedicated line, right? Each packet takes a different route. Suppose this is my machine and this is my colleague's machine. Maybe he's sitting in the other continent, and we are connected to a virtual VLAN. So that's another concept. So, but still we are in the same VLAN. Generally, this does not, won't see more oftenly in the organization setting up the virtual VLANs, but this is what they are moving to now, because they get the more bandwidth, they get the more subnets to enable, and they can connect to each other within being the same network. So that's a virtual VLAN. Uh, so what they do is they have a different, so they don't have a dedicated line towards from source towards the destination who wants to talk. So when they send that, so this machine wants to send the data to this thing, so it won't be carrying the same line. Maybe one packet from here, maybe you have switch here, it is going, and you have another switch here, another packet from here. But when it reaches to the destination, packets gets assembled again, and the data which is to be sent from A to B is delivered, right? That is what the packet switching is all about. Any questions with this thing or any examples you are looking for? Please ask.
Yes, actually, you have given example of virtual LAN in WAN, but generally we have seen virtual LAN in LAN. So, what is different with it? This is new, concept you have just described.
So
Virtual LAN
VXLAN, right?
with the
Virtually
example of WAN.
extensible, right? So you have LAN, you have VLAN, then you have virtually extensible LAN, right? So we have a LAN, okay, suppose we have a subnet, right? And we want to use that subnet, want to break that subnet into other subnets, right? So suppose we have, so that's a subnetting which will be coming in the network part. How it is done, just an overview, what all subnet is all about. So, but for your answer, I would say we have a LAN where the systems are sitting within a defined area. Then you have a VLAN, right? You can virtually assign the IPs, the subnets to those systems which are there in the network, and dividing it in this particular LAN is having a subnet, a big subnet. You divide it into multiple subnets and assigned that subnets to these devices. And still, again, the VXLAN, that's a new concept, which is virtually extensible LAN, where you can extend these VLAN subnets to the other location also. It does not has to be in the same environment. They can be extended over the WAN, right, to the other network.
So according to your this analysis, virtual extensive LAN can have can have multiple subnets device also, right?
Right,
Multiple networks device also.
right.
Okay, got it. Yeah, over to you.
Thank you. So when we are talking about layer 2 protocols, so we have studied one protocol, that is the MAC, and the ARP, which we are using, address resolution protocol, which converts your IP to MAC and tells the switch, okay, this is where my destination is. So we were talking about packet switching and the circuit switching. So again, I will say the packet switching is the data is broken into the packets which traverse independently and reach to the destination. So it has a sequence number assigned to it. So when it reaches to the destination, it assigns the packets again as per the sequence and deliver it to the destination. So layer 2 protocols, there are multiple protocols. If we talk about layer 2 forwarding, point-to-point protocol, layer 2 protocols, but these are not important as per for the SOC analyst. They just had to have the overview, okay, what are these protocols, but by the name. But if you eventually go and see work on the things, you won't be oftenly working on these protocols. So we'll be switching out to these things. So when we'll be covering, so I'll just giving the recap of physical. When we're talking, they are the cables hubs. When we are talking about data link, they are the frames. The data is going in from the switch or a bridge or a wireless access point. And when we talk about the network, right? So now your data. So once you send out the data, it goes through the physical layer. It reaches to a switch where switch decides, okay, where should I route it to? So it has an ARP table. On that, it defines where it has to switch your traffic, and then it reaches to a network layer where your device is the router. It performs the routing. Let us see by an example. So protocols which works on a layer 3, right? These are any protocols you might see starting with I, right? It's like ICMP, IPsec, IGRP, that's a routing protocol. So IPsec, that's a sort of, again, a VPN which you can set up between two organizations. We'll cover this part. Then you have OSPF, open shortest path first. So there are multiple protocols which works on the routing, the third layer, that's a network layer. So the devices which works upon the network layer are routers, layer 3 switches. We can say packet filtering firewalls as well. So packet filtering firewalls, they just look at the source IP, destination IP, and the port, blocks it or allow the traffic. So when we are talking about network layer, we should talk about something about IPv4. So we'll be covering that subnet part through our slides. So when we talk about IPv4, it is of, so how many bits of IPv4 is, anyone?
32 bit.
Right, and IPv6?
So 128 bit.
Right. So that's also a question when a SOC analyst is going out and for an interview, they ask the question, okay, tell me how many bits of IPv6 is. That is 128 bit. So when we talk about security with respect to this IPv4 and IPv6, so can anyone tell me, like, is IPv4 secure or IPv6 is secure? Which one is secure?
IPv6 is more secure.
Right. Why is it?
Not
Okay,
able
let me
to
give you a
recall. I think it's maybe encryption. Maybe, but I'm not able to recall. And it's in hexadecimal format, which may be.
Okay. So when we talk about IPv4, let's get back to the history of IPv4. When IPv4 was designed, right, it was designed for few of the systems. So they were not knowing that the internet would flow, right? That the all the world will be using the computers, right? So that on that basis, they designed IPv4, which do not have a security built in, right? But when we talk about IPv6, that has built-in IPsec. Right? So IPsec is built in IPv6. It provides the confidentiality and the authenticity part. So that authentication and confidentiality is covered in IPv6. So that's the main thing, right? We'll not go into the designing of IPv4 and IPv6 that how was that created, but yes, if anyone asks you this question, right, okay, why IPv4 does not have a security and IPv6 has, that's the answer, right? So IPv6 has a built-in IPsec. So when we talk about the routing, so we have discussed about switching. Okay, when you connect, we want to connect to something which is there in your LAN, your connection reaches out to a switch, looks up for the op table. Okay, judges okay, this is the IP. Okay, this is the MAC address, and then it goes back to that particular device looking at its physical address. Right, that is how switching works. But when we talk about routing, that checks the route table. Right? So on layer 3 devices, we have routers and the firewalls working. So basically the routers and the layer 3 switches. So they have a route table. Right? Okay. If A wants to talk to B, right, through this router, so it will go here, it will check, okay, what is the route for B? Okay, maybe it would be going through this interface, maybe it would be going through this interface. So on the basis of that, it decides, okay, where B is connected to me, right? Okay, it is connected through this route. Okay, I'll go to this route. Maybe A is connecting to google.com. So it reaches out, okay, it is for subnet, which is there, not in my route table. Okay, then I'll go with the default route. That is towards the internet. It goes towards the internet. That is how routing means. So when you are going from a road and you ask somebody the destination, what they do is they tell you, okay, you go there, you go from that road, right? So that's the route they are providing you. So you follow that and you reaches out to the destination. So that is what routing means.
I have a doubt.
Yeah, yeah, sure.
Like for routing, like whichever, I mean, you told me like A has to send something for the B. So in that case, if the A I will be sending, what if the case if there are the multiple rotors and which was if XYZ has been occupied, in that case, like how they're gonna send to the B?
Okay, let's understand this with a big example now. So here you are saying that we have multiple routers and this router is busy. That is what your question is, right?
Yeah, like how it's gonna identify, like I have to select which router or like how generally how does it
Okay,
work?
okay, okay. That's the question. So okay, suppose these are your endpoints, right? In a LAN, let's take it like this way. Right? They are connected to a switch where you will be having the ARP table. Okay, this want to talk to this, then you don't have to go towards the router. Let's take it this way. So that is being done by the switch only. So when it comes to this, suppose A wants to talk to, let's say this as B, it reaches out to the switch, it checks the ARP table, right? Address resolution protocol, where you have the mapping of your MAC address to the IP address. Then it delivers to this point, right? Suppose you don't have that here, you don't have the entry here, right, in the op table. So what it does is it sends you to the gateway. What is the gateway? That's your router. right? So now you have defined, suppose you have the IPsec configured from this router maybe to this router, which is for the, suppose like a vendor, you have a vendor here, and this machine, and when this vendor is having multiple systems here, right? So when, okay, suppose let's give them the name Y and Z, right? So suppose this A wants to talk to Z, right? Now it reaches out, okay, I want to talk to Z. Z means it would be having its IP address. So it reaches out to the switch, it checks my top table, okay, this does not belong to me, not have any my interface. It reaches out, then it sends the data to your gateway, which is a router. So now router will check what route I have in my routing table, which is covering that particular destination IP of Z, right? So that then it comes to know, okay, I have this IPsec configured with this router. So it will route the traffic. It will not do anything. It will just tell you, okay, you go this way. Then it reaches out to this router of the vendor, right? And then again, it will check, okay, this is my IP. It will send the traffic to the another switch, which will be here for this vendor. It reaches out to the switch, then it checks for the IP again. Once it checks the IP, okay, this I know the MAC address for this one. It reaches out to your Z endpoint. So I hope I have answered your question. In case you have any doubt, please ask. So everything is set up as per the route table, which is there defined in this router, right? Whenever the traffic reaches out to this router, it checks the routing table. If it has the entry to that particular interface, so when you place the route table, you make it as in a way that, okay, it shows you the destination subnets, and it gives you the interface also where they are connected from. So that is how a routing table is. So it checks for the destination, route you to that link. And again, here you reaches out to this particular router, then again it checks, okay, where should I route it? Checks the routing table. Okay, here is the switch which would be having the IP this particular machine connected to. Then it sends the traffic to this switch, then again to this endpoint, right? Right. I think Manju, you asked that question, right? Is it clear?
Yeah.
So that is how it is. But as a SOC analyst, again, this is too far to understand. But again, good to have the knowledge. This is how routing is done. You have multiple protocols working, as I told, anything starting with I, not necessarily everything, just like OSPF, BGP, that are also working on the network layer. Right. So let's talk about the transport layer now. So when you talk about the transport layer, so it gives, so when anybody asks you the question, the answer is very simple, right? It manages the reliable and efficient transportation of data. So if you have to send a data, you want that to be in the order communication, right? That is what TCP does. So you can just debate like, okay, UDP is also there. So we'll cover the TCP and the UDP part. So this is the favorite question of the interviewers. What is the difference between a TCP and UDP? Right. So when we are talking about TCP, it's a reliable ordered communication. So when you send the data from suppose A to B, it will go in a sequence. And if they're not going in the sequence, they will first reach to the destination, get in ordered, and then will be delivered to the destination. But in UDP, when the packet is sent from A to B, it is just thrown away. Right? It does not matter. It does not get the acknowledgement that, okay, the data has been reached to me by B. So that is what the difference is. So any doubts with this thing? So TCP is connection oriented and UDP is connection less. So when somebody asks you a question, this is the answer. Why connection oriented? Because it is reliable, ordered communication, ensures data integrity. While UDP is faster, okay, that's one also the difference between UDP is faster because it just throws the data and does not want the acknowledgement. So if we are talking about real-time applications, right, the gaming, game on phones, PS5s, they are using UDP protocol. So you might face a jitter, but you won't get the packet back. Are you getting my point?
Yeah.
Right. So what TCP does to make it reliable? So again, favorite question, TCP handshake. What is TCP handshake? Anyone?
I mean, generally, whatever the data we are going to request, and we get an acknowledgement that we have received the data.
Okay. Before the data starts transfer, there is a TCP handshake which gets completed, right? Between the source and the destination, or you can say the client and the destination. Right. Let's take it as source only. So when source wants to start communication with the destination, first it sends the SYN packet. That is synchronization, right? In response to it, the destination sends a SYN ACK packet, SYN plus ACK. Right? Any doubt? So again, you got the SYN request from source to destination, then got a SYN plus ACK from destination to source. Now again, another acknowledgement packet. So ACK means acknowledgement. That's the acknowledgement. So here, your TCP handshake gets completed. So first source sends a SYN packet, then a destination sends a SYN ACK packet, and then again a SYN acknowledgement packet from source towards the destination. This ensures the reliability and the ordered which we were talking about, the sequence connection. Right? So that is how it is. But again, this is used by the attackers as well. For which attack? Any guesses? Yes, no. So if we are talking about SYN flood attack, right? DDoS, that is being used by the attackers to affect the availability of the organizations using this flow only, right? So when you, so suppose a client sends a request to a server, okay, it sends a SYN packet. So we'll cover this again, but just we are covering this. I'm getting into this point, how this can be exploited by attacker. So suppose attacker is a source here and destination, suppose you have a website hosted, let's say uh, YouTube, right? So if the attacker wants to perform a DDoS attack on this server, what it does is it sends a SYN packet, right? And so YouTube does not know, okay, this is an attacker or actual user. That server sends an SYN ACK packet, right? But what happens is this attacker does not complete the TCP handshake. So when you don't complete the TCP handshake, what happened is this server is waiting for that acknowledgement packet to come to it, and then it can eventually starts the data transfer. But what happened in this case? The attacker smartly does not sends the acknowledgement packet again. And with this is not only one SYN packet, it sends multiple SYN packets, maybe in you can say millions or billions of SYN packets to choke the bandwidth of this server, because whenever one SYN packet comes in, it reserves the bandwidth for few seconds, and then it says, okay, one more SYN packet, one more SYN packet. This like billion packets coming in, choke all the bandwidth. So this server becomes non-responsive for the actual users. So that is what DDoS attack is. Any questions for this one? Guys, this is a very critical component when we are talking about the OSI layer model. So TCP versus UDP and TCP handshake is the important thing to remember.
How the attacker perform DDoS attack in brief? Can you little bit brief about it?
Sorry, I'm not able to hear you properly. Can you please speak a bit louder?
I'm asking Imran. I'm asking how the DDoS attacker, how they perform the data's attacks on server. Can you brief a little bit about it?
Right. That is what I explained. I'll explain it again. Right. So what attacker does is, suppose you have a server here. Again, these servers would be having their bandwidths, and they have their resources here. Suppose they have 8 cores and they have say 64 GB RAM, right? Let's say this thing. So suppose you have this external interface where you have people sitting in here over the internet who access your server from the internet, right? From the external network. This is a server. So so this server does not know if the connection is coming from a legitimate user or from an attacker. So what it does is, the attacker is very smart. It sends out a SYN packet, right? So in response to that, this server sends in SYNAC, right? But here the attackers, what it does is, it does not complete the TCP handshake. It does not sends out the acknowledgement packet. No, it does not. So what happens is, it is not one single connection he is trying to build. He has a bot army. So suppose he has a bot army of 1 billion. So you here also here, and say 1 billion bots sending only SYN packet to this server and getting a SYNAC also against it, but not completing the TCP handshake. So what happens is, when one bot sends a SYN packet here, it consumes the resources here, it gets stored, right? It gets salted until the TCP handshake is completed, and attacker is smart. It is not completing the TCP handshake, right? And if when it is not completing this handshake, resources are being consumed by billions of bots. The same thing is happening. What happens is, this server eventually chokes. The bandwidth is consumed, the resources are drawn. So it is left with nothing, no power to actually respond to somebody who wants to access this application, who is an authentic user, right? So it does not respond to this user now because it is not in a state to respond. So that is how a denial of service attack happens. Any questions? Any doubt?
No, over to you at doubt. I have doubt, but that is, that will be out of the scope of this class. So we'll discuss later on. We can.
Sure. If you have any questions, please share it with Sachin, and I'll be happy to answer it. So when we are talking about TCP, right? So we have some protocols, right? Suppose like FTP, that's a file transfer protocol. So guys, you have to remember the protocols which are there, because you would be seeing those in the payloads when you're working as a SOC analyst, right? So you must know what is a FTP, file transfer protocol. It uses port number 20. So these are well-defined ports, well-known ports. So this is used for data. Then we have another FTP port that works on port 21. So I think I have covered this in my slides. I'll just switch over and show you. Yeah, we have maybe the ports here, they are written, but yeah, okay. So we have some ports working on the application layer as well. So FTP, HTTP. So this is what I'm telling you from the broader perspective, because you would be getting these questions. Okay, what is a port number for FTP if you are being interviewed for SOC L1? Okay, so what is port number for HTTP? What is HTTP? So maybe who's working in the networks would be knowing it already, but we use it on daily basis. What is HTTP? Is hypertext transfer protocol. It uses port number 80, right? We have HTTPS port number 443. What is the difference between HTTP and HTTPS? Anyone?
HTTPS is more secure than HTTP.
Sorry.
HTTPS is the secured.
Why it is secure? So I'll just get to the point. When you'll be answering this question, you have to like in the interview. So here we are discussing what will be the questions when you will be interviewed for, or maybe in the real application of the things. So when you're dealing with HTTPS, you know that so as a basic network administrator guy, you know, okay, S is there, it is secured. Why it is secured? That's the question for a security guy.
Uh,
So when we talk about, yeah,
So
okay, I'll answer this question. So what is HTTPS brings is it secures your connection, right, with the web browser. Why? How? That's the question. So we need the security, the confidentiality part, right? So if suppose Manju is sending out the data, he wants to talk to his a friend, or he wants to connect to his bank website, let's say this way, and he wants that connection to be secure, does not want to anybody to sniff in and check that data what is being transferred. So that for that you need encryption, right? You need encryption, you want to ensure that the integrity is maintained. But what he's more focused about is the confidentiality. Okay, if I'm supplying my username and password to my bank website, it should not be in the clear text. If somebody gets the data also, he won't be able to decrypt it. So how would he be able to achieve the encryption when you're talking to a bank server? That is being done through SSL handshake. So when we were talking about TCP handshake, it was just to set up the TCP oriented connection with the server. But when we talk about security, right, is we are not using IPv6 oftenly, but still they are being used in the new mobile phones and the new systems which are coming in. But if you are using IPv4, so you need security. Anything which is going out should be checked in, right? So we have SSL handshake. So what is SSL handshake? We'll cover this when we'll be starting the SOC fundamentals, right? So this is the answer. Why we need it? We had to ensure the confidentiality part. So that's the main story. So when we are talking about security, we are only bothered about confidentiality, integrity, availability, non-repudiation, and authenticity of the data. And we'll during this course, I'll give you the applications why we need it. Because when you'll ask it answering this question, why we need HTTPS? So okay, it provides me security. How? It provides me the confidentiality, so that if I'm talking to someone, so the communication should be encrypted. If anybody gets hold of that data, it will not be used. It will be of no use until and unless it has the decryption key, which is more oftenly we have advanced level of encryptions. Until unless you have quantum computers, you won't be able to decrypt it. So that is what it is. So Chacha family is a new encryption which is being used, right? So these all things we'll be covering in the cryptography modules when we'll be switching on. Any questions to this thing? So I'll just cover this ports part again. So you have some well-defined ports. You have SMTP, which works on port number 25. You have Telnet, port number working on 23, SSH 22. Then you have POP3 as working on 110 for receiving of emails. Okay, many people think like, okay, SMTP is a mail protocol, POP3 is a mail protocol. Why do we need two protocols? Anyone? So I think we have guys from network team. I think you would be able to answer this question if you have set up this mail gateways and have configured network for this.
One is for the sending purpose, and second one is for the receiving purpose. SMTP is for the
Absolutely right.
sending purpose.
So the SMTP we have, it helps the users for sending of the data, and POP3 helps you for the receiving of the data. Right. So we have a well known ports.
So in POP3, I have a little bit curiosity about the POP3 and IMAP. When we are selecting POP3 and IMAP, So, what is the difference between POP3 and IMAP?
Okay, so as we discussed, POP3 is post office protocol you use is for the receiving. So both are the retrieving messages protocol. So if we are setting up a mail server, we set up either via POP3 or via the IMAP. So if we talk about specifically about POP3 and emails, if you are receiving it, you download that emails and store it on a local server, right? If we are talking about POP3, right? And you can access it from maybe from a very single device, right? So when we talk about IMAP, they are stored on the server. So when we talk about POP3, you have the mail here in your system, it gets deleted from the server, right? And we talk about IMAP, emails are stored on the server. So if you want to access them again, you can go to reach to that server and get that on your machine again. So if you have deleted it from the system using POP3, boom, it is deleted. IMAP, you still have it on the server, you can retrieve that email. I hope I have answered your question. So if you're talking about mail servers, IMAP, POP3 local device.
Yes, thank you.
Right?
Thank you, Imran.
Thank you. So I think we are over time. Let me just give you the last thing. So somebody who is not working in the networks won't be familiar with this thing. The well-known ports. So we call well-known ports. So there is a range of ports which we have for well-known. That is from 0 to 1023. These are well-known ports, right? So they are defined ports. They are known to everybody. Okay, this port is used for this one, but you don't have to focus on all the ports. You just have to focus on few of the ports which I have told and few of them which I'll be telling during these sessions. Then you have the registered ports, which covered from 1024 to 49151. So guys, you have to memorize this thing because I don't have any way to make you memorize this thing. This is what it is. So these are well-known ports. These are registered ports. Then you have the private ports, or you can say the dynamic ports. That's the range from 49151 to 65535. So we'll not go into the depth of the things why we have only these ports, because again, when it was designed in the way that they were not knowing that they would be requiring more ports than 65535. So ports, they act as a gateway for the services which you are using. Suppose you are using FTP, the port is 20, right? If you're sending the data, if you're controlling it, then it is 21. If you're using HTTP, that is 80. So that's a gateway, right? So if we talk about specifically about servers, when we talk about security, you reserve the ports, right? You block the non-receiving ports. If you have a server, we don't allow 445 until explicitly asked by the business. This is the SMB port, which was exploited in the first ransomware WannaCry. Right. We'll cover these things during our SOC sessions. We'll be moving out of the networks and getting into the security discussions. So I think, Sachin, we are good with this session as of now. Guys, if you have any questions, please ask.
Yes, guys, you can ask your doubts finally.
So I have a doubt, Imran. So can you show, because previously you said something about the DDoS attack, right? How the DDoS attack happens and how a server will go down because of the DDoS attack. And can you show something like on a SIM tool? Because we will get these responses from firewalls and other tools to the SIEM tool there is some alerts, right? So can you show us how the alerts will be, or what are the details we will collect as a L1 engineer from that?
For sure. We'll be covering all these parts during our simulations and the lab activities when we'll be moving to the SOC modules. This is just, so
Okay.
yesterday I told, right? So this is the fundamentals which we are trying to set here. What we'll be covering will be the simulations and the real-time attack scenarios and the payloads which we'll be looking, and the analysis which has to be done in the particular attack scenario. So all these things will be covered, right, from the tool perspective, from the real examples.
Okay, thank you.
Yes, Dinesh. Actually, this is the day two class, and this batch will run around 2 months, okay? 2.5 months.
Uh-huh.
So everything we are covering L1 to L3. Don't worry.
Thank you.
Yeah. Anyone else, if want to ask any doubts? Otherwise, we can sum up the session for today, and we can connect by tomorrow. Anyone,
Hello?
Vishal, Vinayak, Saurabh?
Hello.
Yes, John, please
Hello.
ask.
Yeah, I would like to ask on okay, which are some of the, because I do not get much of the whatever, I always come late. I wanted just you to brief me on some of the penetration test tools which I use.
So you're asking about the penetration tools, right? The just like the
Yeah.
AAD internals. So if you
Yeah.
go about the OpenVAS, Nessus, so that is what the vulnerability management about. So you are talking about the red teaming activity, right? The Nmaps, the Recon Menges, and the other Metasploit tools which are there, like SQL Map. Yeah. So will not be covering all the tools. Okay, from the red team perspective, what is a burp suit, what is a GoBuster tool, John the Reaper, which is used for password cracking. We'll be just touching the base of that. Uh, if you want to explore the red teaming activity, I think we can arrange another session for that. So that will be more focused on from the attacker side. But here, as we are discussing about the SOC analyst side, yes, the important thing is you should know how the attacker will try to compromise your environment, but at the same time, we are more focused from the defender side here, right? So we'll be touching the base on these tools, which attackers use generally for the reconnaissance and the execution, persistence, and delivering of their tools to their network, covering the cyber kill chain, and the MITRE attack frameworks as well.
Okay. It's okay. Thank you. No problem.
Then
Thanks, John.
And
yes, sir.
maybe
What is Splunk?
yes,
Splunk,
maybe
what
if
is
they hello,
cybersecurity?
hello,
Yes, John.
hello. Yes. Do you people have like a deep kind of specific course for this? Like maybe after this session, if somebody want to enroll for the particular course, which he has like a deep session on this topic generally on penetration testing and all uh, hacking and the
Yes,
rest. Do you have like
yes,
yeah?
yes, yes.
No
You
classroom,
might
yeah.
connect with Sachin, right? He'll give you the
Yeah.
overview of the sessions which we have for penetration testing and red teaming activities. Yes.
Yes, John. I'll connect you after this session. We have separate batch for pen testing level, okay? Advanced pen
Yes, sir.
testing.
In yesterday
Okay.
class, you
Okay.
were
Thank you.
giving some Splunk. What is Splunk in cybersecurity? Splunk. Uh,
Okay.
it is
So
what a
I was telling
server
about the
is what?
SIM tools, right? Sorry.
Okay. Windows. Okay.
So we were talking about Splink SIM tools, where the analyst for the performs this monitoring task, and that's a security information and event management tool only. So that performs the log call collections. As I told yesterday, it's an integration of log sources. Then the engineering team does the parsing and places the correlation rules. And once that correlation matches, alert pops up on the screen, and that's the way that's the time the SOC analyst work starts. So that's a powerful tool that I would say. But not only related to Splunk, there are many tools. So as a SOC analyst, uh, one should not focus about the tool very much, but yes, they should know how to use the tool, and just to place the queries, and if they want to make the reports, the automations, they have to check the dashboards. But managing of the tool is done by the same engineering team. We'll be touching base on that as well, how they do it, because the analyst, you should know what log sources, how to integrate them, but not in great depth again. So we'll be more focused on the analysis and the investigation part.
Okay.
Hello.
Yeah, hi.
Like I just found out. So generally, like what is the network architecture? I mean, like the basic, like the foundation of network architecture of any company. Like if you take any like example, if you are working, so what would be the network architecture of the company? Like
Right,
how?
Manju, did you join the call yesterday? This discussion?
No, was my first class. Like
Oh,
I
okay, okay. We covered this architecture yesterday, okay, in a broader way, with the data centers, how they're interconnected. I'll get back to this again, right? I'll explain this again, how a real architecture looks like. Just an example of giving one of the organization which I did yesterday. So, so we can cover this again. Not an issue.
okay.
Yes, even I can, share you yesterday recordings as well, so that can have clarity, right? So yes, okay, I think that's good enough for the day, Imran sir, right? And
Thank you, Sach. Yeah.
we can connect by tomorrow, same time,
Okay,
and
okay. Thank you.
deeply for SOC. Yes. Thank you,
Okay,
guys.
thank you
Thank you.
everyone for joining the session. Have a
Yes.
nice day ahead. Bye.